Welcome to a new test and teardown video. This time we're gonna stay a little bit in the vintage section. I just came home from another flea market. Look at that beautiful old thing I got here. The company that made these is called Cossor. They are from England, and it should be written underneath that label. Because what I did is I googled a little bit on this FM receiver alignment generator model 1324, and then I get some hits on Radio Museum, and then I can see the pictures, and so I expect to see this text written here, and I can also see some paint. The black paint here hides the company name. Adding stickers to instruments like this is just a very, very annoying thing. A lot of companies did this to prevent people from stealing instruments, but I really think you should add labels on the top or on the back. I don't know, this is just stupid. Also, what I've been looking at is their missing knob, and that is a chicken head knob like this one, and I think this is more or less a standard model, so I should be able to replace that one as well and make it more or less original looking. Yes, this is an FM receiver alignment generator, so it can generate a carrier in the FM band. I haven't yet figured out what the numbers here on the inside is really good for, but the outside should be the frequency in megacycles for the FM radio. Of course, we got two attenuators for the FM or the RF carrier level, audio output level, and then there is an internal sine wave generator, or you can turn it on and off, internal or external audio frequency. And then we got some very funny terminals here, right? So earth is, yeah, that's quite clear, audio output. Signal generator is probably the output from the audio signal generator, right? And here is the funny signal X. I've been looking a little bit on the schematic. There is a schematic on Radio Museum. It's a little bit in a bad quality, so if you happen to find a schematic in a better quality, please upload it to Radio Museum, because you can do that and they will be super happy to get nice updates of stuff in better quality. I've been looking at the schematic about this signal X, and it looks like it is an input-output kind of signal to the audio generator part of it. It's of course tube-based, and it's from about 1961, and we'll find three ECC 81s in here, and one pentode and one rectifier tube. Instead of just powering up, I think I should open it and have a little visual inspection first. I always recommend doing that on stuff this old, especially when you don't know exactly the state of this. So yeah, let's open and have a little look. So somebody is the only one that sells this. It's called Danbridge, a company that buys and sells stuff. They also design their own products. Well, that's probably the voltage selector. That was a little bit funny. So this top lid here, it's not even screws. It's those you turn and then flippity flap. And then there's a little secret compartment, and then you'll see. But why do this? What's the whole idea? I don't understand this inner. And that was definitely voltage selection, and it is set for 2, 3, 4 volts. Oh, we even got a serial number in here. So how are we going to open this thing? So this is a classic way to open old tube equipment. You normally just remove the front screws like this and pull out the entire frame with everything in one go like this, and then off you go with the case. So that's quite standard. Here's a mains entry filter, I guess. And then red and black wires from mains entry. I'm not super happy about that. That will be the three ECC81s. I bet that is the little pentode for the audio oscillator, and that's probably the rectifier if I'm not mistaken. But I don't see any blown up capacitors. This one could be a little bit crusty, but it's not super bad from this direction. We got some alignments right here. I'm not going to touch anything. It's always fun to see how much off it is to begin with. And this is the bottom. So, I mean, this transformer is like really, really big for this job. It's also looking a little bit. Nah, it's okay. I think we passed the first visual inspection. I'm not super worried. No, this is not super good, but it's also not super bad either. It's always a good idea to clean up all this nasty stuff. Mains entry goes via 2 fuses, and the switch only disconnects 1, but it's actually a double set. Why didn't you take the 2 inputs and put them through both of the contacts, or at least put the 2 contacts in parallel? I don't know. RF output, and here you go with your sexy attenuator. It's good for like 100 megahertz. Really? And then there's another attenuator in here. It's just a pot meter in a box. Yeah. This is how you do it. And the big one was indeed the rectifier. And that bulb, if that is still working, I don't know. I should probably change that. But other than that, I think we're ready to power it up and see if it takes the fuses. So let's try and do the first power up. I tried to protect myself a little bit here with a chassis going to earth, protective earth here. So, and this on-off switch here is in off. Metal is not touching anything. Okie dokie. Mains is applied and we don't see any current. And we go on, and light is on 20 watts, and then it goes of course down, and 19, and then let's see what happens. 25. So stables at 26 watts. I don't smell or hear anything bad. Oy, oy, oy. Here we go. We got some output. Okay, and this is also affected by that one. How about the audio? No. So that is not the thing. Okay, that is definitely the level. It looks a little bit weird with those. All the overtones like that, so I didn't expect this to be a super nice and clean oscillator, by the way. But yeah, we see something. This looks a little bit like a job for a spectrum analyzer and not a scope. Yeah, I think we should try and do that. Definitely it is responding to all the knobs and dials and stuff. Here just, yeah, okay. So that is how it works. But it looks like it's alive. Yeah, I think I will go and get a spectrum analyzer instead. So now we got a spectrum analyzer instead, and we're just gonna redo exactly what we did and see if it powers up. At the moment I set the center for 100, so 0 to 200, and let's see if it warms up and if there's any. Okay, this connector is probably I don't know what I would call this crappy connector here. That's what I'm having a little bit of problems with. Amen. But I do have some kind of output, right? But it's just, I don't see a peak. I was expecting to see a peak. Maybe we should span like 500. Where's the peak? It's just all over the place. Really? How's that possible? So how about we just check the tubes? So it's super easy because the first 3 here, those are ECC 81s. And I just happen to have a machine set up here to do ECC 81s. And this is actually the best one of the 3. And that one is actually fine. Oh yeah, look at that. This is pretty good. So 1 is good, and the other 2, those are bad. See, the first thing you want to do is measure the high voltage is here. So there's a big inductor between the 2 capacitors. And it's about 180 volt, and you'll see a few volts of AC on the input side, and you'll see almost no AC, but you'll see a nice clean DC here on the output side. So that means, you know, all this high voltage stuff is nice and clean and good and working. And here is the first tube in the schematic. That is the audio oscillator. It's a pentode, but it's only using one of the grids, by the way, so they could have used the triode if they wanted to do that. So that is the audio oscillator here, where you select the or adjust the audio output. You can't change the frequency, so I've set up my scope here to measure that output. And when I dial around with the level here, see, so this proves the audio oscillator works, and that tube is perfectly fine, so I don't need to worry so much more about that. I need to figure out why my output is not up and running. After a little bit of poking around with the tubes and new socket, poking around like this in the sockets, look what we got here. So this is 90 megahertz, only 1 megahertz of span, and what you can see is this is the, see? Ooh, yoy. This is the level. So it's of course supposed to deliver a very low level for a radio receiver. And if you do like this, it's of course completely invisible, super low signal. But that is definitely what you need for a radio receiver. It's much more sensitive. But yeah, it actually works now. Haha. So that is all I wanted to say. I'm now gonna go and put a new knob on it, so it's gonna be nice and fine again. And thank you very much for watching, and have a good day. Bye bye.